Here we go. So here's the agenda for today. We're going to be talking about if you've ever been to one of my webinars, you know that I always talk about the motivations for what we're talking about. So we're going to talk about the motivations for wolfCrypt FIPS 140-3 level 1. We're going to go into the target distros that we're talking about. And we're going to look at implementation stories for the and target applications for how we're going to be doing this. And then finally, we're going to be looking at our IGEL case study. And we'll get more into detail about the case study once we get to that point in the presentation. So again, let's start with FIPS 140-3. This isn't going to be a detailed discussion about FIPS 140-3. We have many webinars that are recorded on our YouTube channel about FIPS 140-3. So you can go check it out. You can go check out our YouTube channel. And right after this slide, I'll have a link to an excellent FIPS 140-3 webinar recording done by my colleague Caleb Himes. He's our utmost FIPS 140-3 expert within wolfSSL from the engineering perspective. So for FIPS 140-3, everybody should know that we have our NIST FIPS certificate 4718. This, you can find our certificate at the link given right there, or you can even just Google FIPS 140-3 wolfSSL certificate 4718, and it'll take you to that link right away. Notably about this particular certificate, it's the world's first SP 800-140 BR1 certificate. And, you know, that's a really long name. And really what that entails, what it means is that it's the first certificate that was done through an automated checking system. There's still a lot of human interaction and human verification involved, but part of it was automated. What's really the most notable thing about our certificate is that it sunsets in 2029. So that's like, you know, years and years away. We're going to be talking about other FIPS 140-3 certificates. And we're going to note that most of them are not sunsetting very far away. In fact, they're just interim certificates. And, you know, beyond 2029, right, you know, you might think, okay, in 2029, then what? Well, we're already in progress with new certificates so that beyond 2029, you're going to have another certificate to grab onto. And that's what we call the laddered approach. For our customers in their FIPS 140-3 journey, there's always going to be a new rung to grab onto on the ladder that you're on in your FIPS 140-3 journey. And it's going to always be this way, and it always has been this way. We've always had a cert available. As I had specified earlier, from a technical perspective, FIPS 140-3, our FIPS 140-3 development at wolfSSL webinar was done by my colleague Caleb Himes, and there's the link to it right there. Okay, so let's talk about the distros that we're talking about. And so before we talk about the distros that need this, let's talk about distros that already have FIPS 140-3. And we're talking about, you know, Red Hat, Ubuntu, Alma Linux, Oracle Linux, SUSE Linux, and Rocky Linux. Notably, Red Hat does have some full certificates, but again, most of them are interim certificates. As far as I could tell, for Ubuntu, Alma Linux, Oracle Linux, SUSE Linux, and those certs are all interim certificates. which means that they're only for 2 years and they're all sunsetting next year. So, if you're going to go with them, there's a little bit of uncertainty as to what's going to happen after 2026. And, I can't exactly, I don't really know how the process for getting FIPS 140-3 certification went for them, but we can kind of guess and make some interesting, maybe make some interesting guesses about that. And we'll talk about those guesses in a future slide. Rocky Linux is in a different position. They're on the in-process list. So they haven't actually gotten certified. They're still going through the certification process. And we're guessing they'll probably be available by late 2026. Note that when you license with us, again, you're getting a FIPS 140-3 certification, and the license is perpetual. So you're getting something that's going to last all the way till 2029. And when I say perpetual, I mean the license is perpetual, but then the certification will expire in 2029. But again, that's worth it because you're only paying one licensing fee at the beginning. So what distros, actually, I should probably highlight that a bit more. With all of these solutions, these other distros, their licensing terms are per seat, per and per person, and like if you're looking at a large deployment, you're going to start seeing the costs multiply and build up, right? With wolfSSL, it's a one-time fee and it's a one-time licensing. It's a one-time licensing fee. Sometimes we can be far more flexible than any of these distributions. And if you want to understand more about our licensing terms, please do get in touch with fax@wolfSSL.com. Send an email to fax@wolfSSL.com. So what distros do need FIPS 140-3? We're talking about things like Yocto, Arch Linux, Fedora. I mean, the list is right there. You don't need, I think we can all read it. You can basically kind of get an understanding of what we're targeting here. Note that these are maybe a little bit less enterprise targeted. These aren't as enterprise targeted distributions. But what that means is that, we can help medical devices, medical device manufacturers get into these markets. We can help, printer manufacturers who need to get their printers FIPS certified. They're probably not going to use big, massive distros for such as the ones on the previous slide. And so they're going to want something smaller. So we can help them get onto get their FIPS 140-3 journey started. So these are more smaller, more compact distros, and distros that might be used on medical devices, for example, or in the medical field. So and it's not just these ones. These are just the most popular ones that we can think of. You can name your favorite distro, and I'm pretty sure it's going to need FIPS 140-3 on it. So let's talk about our implementation stories, and we're going to begin with OpenSSL. So we have, if you look at OpenSSL, it's got several release branches. The ones that are relevant, the oldest one that is relevant is the 1.0.2 release branch. And what we do there is we override the crypto within OpenSSL's Libcrypto, and we do that with an engine. That's the Wolf engine, and it basically gets loaded underneath libcrypto and overrides all the cryptography implementations within libcrypto. So this is for if you're using TLS 1.2 and earlier. This is a very old, very old release branch, and it's not even maintained by OpenSSL anymore. Now, a little bit newer, but still fairly old release branch of OpenSSL is 1.1.1. It happens to still use the engine interface. So Wolf Engine will also work for OpenSSL 1.1.1. And this release branch supports TLS 1.3 and all the earlier protocol versions for TLS. But it also supports ED448 and ED25519, as well as X448 and X25519. Again, it's old. It's still used fairly extensively out in the wild, but again, it's no longer updated by OpenSSL either. Now we get into the newest series of branches, what OpenSSL itself calls the 3.x.y series of release branches. And we'll provide, and instead of the engine interface for external cryptographic providers, they now have what's called the provider interface. And so with the provider interface, it no longer is compatible with engines. So now we have a new product called wolfProvider. And what wolfProvider does is it overrides all the cryptographic implementations within libcrypto on a 3.x.y branch. So what's really interesting about this, about the provider, is that it actually allows for support for algorithms that libcrypto didn't even know about. So, for example, post-quantum algorithms, you can add support for post-quantum algorithms in your provider, and wolfSSL will be, or not wolfSSL, OpenSSL will be able to use them. Notably, there's in the 3.x.y, there's no backwards compatibility with the 1.0.2 and 1.1.1 branch of releases. And so there's been a lot of kind of, debate and churn in the market as to whether certain organizations want to move on to the 3.x.y. But this is the only actively supported release branch by the OpenSSL team. So how do you know whether you should be using wolfProvider or Wolf Engine? And the simple answer is you run OpenSSL version, and if it tells you it's 3.something.something, then you need wolfProvider. Otherwise, you need Wolf Engine. That's about it. Now, as an end user on these systems where wolfSSL is going to be bringing in FIPS 140-3 across the whole spectrum, you're not going to have to worry about that. This is just going to work via under the hood plumbing. So if you look at our OSP repo here, that OSP repo has a lot of projects, open source projects, that we're about to list. And normally we support those projects via our OpenSSL compatibility layer. But for this full Linux coverage project that I'm talking about in this webinar today, we're actually going to be using wolfProvider and Wolf Engine to support them. And we're talking about a wide array of projects within that repo, right? We're talking Apache, we're talking, S-Tunnel, massive amounts of projects that you'll be able to kind of use with wolfCrypt FIPS underneath it via these overridden crypto implementations that are overridden via the Wolf engine and Wolf provider. Okay, let's talk about NSS now. How are we going to override their cryptography? So I hold as an example here Firefox, because everybody knows, Firefox is a browser. What a lot of people don't realize is that there's a whole very complicated architecture, software architecture underneath Firefox. They've got a UI library, a rendering library, localization module, and various other libraries. That's what the dot 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 kind of means. One of the libraries, though, is NSS. And NSS stands for Network Security Services. And within that library, there are various submodules, such as a module for supporting TLS and CMS and various other protocols. Notably, their cryptographic implementations are wrapped in a library called a library that implements PKCS11. So if you're not familiar with PKCS11, it's basically a standardized API for accessing crypto. Um, so it's an API that's specified both at the IETF as well as the OASIS Standardization Committee. Um, and this API, if you can implement a library with this API, basically you can push and pop, like basically replace any one crypto implementation with another. Um, where this becomes useful is around HSMs. Many HSMs, the kind of HSMs that are like rack mounted in a locked room, in a server room, those all implement PKCS11 for interoperability. Um, and what we here at wolfSSL have done is we actually have a PKCS11 implementation. We call it Wolf PKCS11. And what happens is that we can load in our Wolf PKCS11 library into NSS, which will then override the PKCS11 default library that is part of NSS. And Wolf PKCS11 obviously will call into wolfSSL, and wolfSSL will have wolfCrypt FIPS underneath it. And so you'll be able to use our FIPS 140-3 certified algorithms within NSS and by extension within Firefox. So this is kind of a fun little slide. And this will go down in wolfSSL's history and lore. When we first started doing this project, NSS was one of the first projects that we wanted to kind of override and kind of do shall we say, a proof of concept. And so in order to prove the proof of concept, the first thing that we loaded with wolfCrypt FIPS overriding the PKCS11 interface was this Rick Astley Rick Roll YouTube video. And so basically when the product manager asked, hey, does this really work? He was Rick rolled by the developer. And to really really when we say that a picture is worth 1,000 words, it really is. You can see here that what we've done is we've overridden the NSS built-in module with our wolfSSL HSM slot with wolf PKCS11. So what applications are supported by NSS via wolfCrypt FIPS? So obviously, as I had mentioned, Firefox, and also obviously Thunderbird. These are both libraries by Mozilla sorry, applications by Mozilla that use NSS for their cryptography. When you download NSS, it comes with a whole series of tools. Some of them are kind of demo-like, for example, for doing demo TLS connections, but a lot of them are for doing your own certificate management. So for doing CA operations. So you can have like a mini test CA, and that's what NSS tools are for. Network Manager also uses NSS under the hood, and we'll get to questions at the end. And libpopler is a PDF rendering library, and which has some cryptography under the hood, and it uses NSS as well. And so when you're using NSS in these situations, the PKCS11 library is overridden again, and it's wolfPKCS11 underneath, and obviously FIPS 140-3 supplied by wolfCrypt FIPS. So Libgcrypt and gnuTLS are two separate libraries, but we took very similar approaches to them, so we've combined them into kind of one set of slides. And so I'm just going to read off what it says right here. The approach to libgcrypt and gnuTLS is to leave as much as the upper architectural layers as intact as possible, and only have a thin shim at the bottom that overrides the original cryptographic implementations, and instead calls into wolfSSL, wolfCrypt FIPS. So what we generally call this within wolfSSL is we call this a rip and replace. So we've ripped out the low-level crypto implementations and replaced them with wolfSSL. And of course, once again, wolfSSL calls into wolfCrypt FIPS. The advantage of this approach is ease of maintenance and no need for applications that depend on libgcrypt or gnuTLS to be modified. The intention here and the goal here is to make it so transparent that you don't even need to rebuild the applications that link against gnuTLS and libgcrypt. So projects that are supported by libgcrypt. So one thing that we are very proud of here at wolfSSL is that many of our customers are printer manufacturers. And so why does that matter to us? Because now we can override the crypto underneath CUPS. And CUPS is what talks to those printers. So it's really nice to be able to have the same library underneath both, the same cryptographic implementations underneath both CUPS as well as the printers that talk to CUPS. This works for the NM project, systemd, FW update, libnice, notably VNC as well. VNC is a really widely used virtual desktop system. And so that's really nice. And rsyslog, we can override the cryptography under rsyslog. And finally, we come to the Linux kernel. So, what is wolfCrypt FIPS as a Linux kernel module? Well, if you look at the Linux kernel, much like what we were talking about with Firefox, there are all these kind of modules and within the Linux kernel. There's memory management module, there's a process management module, there's the hardware bus management module, and various other ones. What some people don't realize is that most of the, specific support for drivers is done through kernel modules. So there's a sound kernel module. Bluetooth, for example, is done via kernel module. Ethernet is another big one that's done through kernel modules. And one of those modules is cryptographic. One of the type of modules out there are cryptographic implementations. So you can build libwolfSSL as a kernel module. And that's exactly what we do. So within the Linux kernel itself, there is a default implementation for all of the cryptographic algorithms. So this default interface, this default implementation has an interface. And really the way you access this default implementation is by passing in strings and a priority. If the priority is 0, that means, yeah, just if the priority is low enough, then it just uses the default. Sorry, the priority is set by the implementation, and the default implementation is set to 0. So if you wanted to use ECDH and there was no other implementation that, sorry, we'll get to questions and comments at the end of the presentation. If getting back to this, if you wanted to use ECDH and there was no other kernel module loaded, because it's there's no other one, and its priority is set to 0, you'll just get the default. Once wolfSSL's kernel module is loaded, we would set our priority higher. And then because our priority is higher, for example, if you were looking for ECDSA, then wolfCrypt FIPS ECDSA implementation would be used instead. And so as you can see, we're overriding the crypto there, and you would have FIPS 140-3 certified cryptography within the Linux kernel. So what are the use cases here? The main use cases are for offload of disk encryption and network packet flow management. For disk encryption, it's pretty obvious, right? It has to be done in the kernel because it's disk encryption. You're not going to have an application doing this because the application would have to decrypt itself. That doesn't even make sense, right? So all disk encryption has to really be done in the kernel. For certain networking protocols and applications, all the work could just be done in the kernel. For example, VPN, right? It's just a kind of routing system. It doesn't actually need to enter into the userland space, right? It doesn't need to be brought into the userland address space. And by not doing that, it's super fast and efficient. But by just keeping all of the cryptography and all of the data and all of the packets in kernel space. And this applies to VPN protocols, IPsec, MACsec, any kind of TLS offloading or routing, and notably WireGuard. WireGuard this is how WireGuard is fast and efficient. So this is for kernel. It's really important to note that the use cases for kernel space to kernel space applications. This kernel module, the wolfSSL kernel module, can also be accessed by user space applications via certain kernel APIs. But then those performance advantages I mentioned disappear. So it's totally fine to do this, to access this from user space, and we have example code for that. It's just that you're better off building a wolfSSL in the user space. And again, I am not the Linux kernel expert within wolfSSL. That's my colleague Daniel Posner, and he did an excellent Linux kernel module with FIPS 140-3 webinar, and the link to that webinar is right here. I suggest if you want to get more deeper into the technical details and implementation kind of gotchas that he bumped into, you can have a look at that webinar. So as you can see, to summarize that whole section right there, basically we're talking about wolfCrypt FIPS as the one crypto library to rule them all. What are the advantages of this? Well, the advantages of this are a reduced attack surface and really only a single implementation to certify. This is a huge point that I think we really need to highlight here. When you look at the previous, way back in the previous slides where I talked about all the other distros that have already gotten their FIPS 140-3 certification and validation, it was interesting. Um, most of them, just about all of them, were interim certificates, 2-year certificates. And why were they only getting interim certificates? Probably because it was just so much work to certify against 5 different libraries, right? If you look at the way those distros have their FIPS certification done on the NIST website, you can see they have individual certificates for OpenSSL, NSS, Libgcrypt, gnuTLS, and the Linux kernel. So Alma Linux has 5, Red Hat has 5, Ubuntu, canonical Ubuntu has 5. So this is overloading our overloading the FIPS labs. They're probably going crazy. And not only the FIPS labs, but also the CMVP at NIST. They're having to go through all of these certifications and all this work over and over again. Our approach is to get you know, a certain small boundary within wolfCrypt. Um, uh, and it's a minimal boundary. And it's very easy for our labs to interact with us because we are small and nimble. Our what's within boundary for us is very small and nimble. And so they were able to get us through FIPS 140-3 certification with a full 140-3 certificate sunsetting in 2029, right? And what that means is that it's going to be easy for us to get the next one as well, and the next one, and the next one. We're never going to have these interim certificates. We're going to get full 5-year certificates moving forward. And so this again speaks to the laddered approach that we're taking. And so you're never going to have these uncertainties that we have with these interim certificates. Okay, let's talk about IGEL and the case study we have with them. So a little while back, IGEL had an event and they announced that they were working together with us. Um, this project is actually being driven by them. This project will be integrated into their products. Um, so what's going on is that, we are experts in how we use Linux. Every single one of the members of wolfSSL, the engineering team anyways, um, knows POSIX, uses Linux on a daily basis. But we're not familiar with every single use case out there. IGEL is. They manage Linux deployments, and that's their bread and butter. So it's great for them to come. It's great for us to have them come talk to us because they can help us um, with driving requirements. Understanding the end user, understanding user stories and stuff like that. So this is all part of our agile process to have IGEL come in and help us understand our end user. So we talked about, you know, a bunch of existing um, distros that already have FIPS 140-3. And you might be wondering, and we were wondering, and we talked to them, and we've had conversations with them, but you might be wondering as to why they're not leveraging something like Red Hat or Canonical's FIPS 140-3 certificates. And let's be clear here. It's these 4 points. We hold great flexibility in licensing, right? if you email fax@wolfSSL.com, we'll have a reply to you within the day, within 24 hours. And then in that reply to you will be a request for a meeting. And within, if you're open to it on that day, we can have a meeting and we can talk about what your needs are in terms of licensing, what your preferences are. Be it be, and you know, if you talk to someone like Red Hat or Ubuntu, Canonical Ubuntu, or one of those other distros that already have FIPS 140-3, they're going to want a per seat subscription, right? Um, we can do that. We can do a per seat subscription as well. We're very, very flexible, but we're not, but in general, that's not to your advantage. So we can be very open and flexible about how we're going to be doing our licensing. Um, for us, another good reason IGEL wants to use us is our support. I happen to be what we call a support captain within wolfSSL. We have by far the best in-class support system within wolfSSL. When you look at other cryptographic libraries, there's just no comparison. We have quality of service standards that we follow. We have a whole support system that reminds us that we need to get back to customers within a certain time period based on their support level. We also have an a very, very extensive policy on vulnerability reports and how we respond to them. Um, we have very high standards with regards to vulnerability fixes and how long that they should take. On average, our median time to response to fix is 72 hours. In general, we will have a fix within the week from a vulnerability report. That is to say, if it is evaluated by us to be a vulnerability. Um, and again, I keep on harping on FIPS 140-3, our laddered approach. IGEL knows that our FIPS 140-3 certificate sunsets in 2029. Um, and after that, they're going to have another FIPS 140-3 certificate available once that expires. And finally, consulting. Agile is a agile organization. So they're going to have customers that are going to come up to them and they're going to say, hey, we need this support for this. We need support for that. And Agile is going to want to oblige. And, you know, one day they're probably going to face um, an application that needs support for something that isn't using one of the 5 libraries that I specified earlier. And so they're probably going to need to come to us and say, hey, can you support this? And yeah, we'll do it. No problem. We're extremely responsive when it comes to new ideas. We're a very, very customer-driven company. And so if Agile is going to need a new security library supported, we'll get that done for them. No problem. Okay. That comes to the end of my presentation. I noticed there were some questions that came up. Shizuka, did you want to start the ball rolling on the Q&A?
Yeah. So there's a one question. Do products like pfSense BSD based have to get 140-3 in the future?
That depends on how that pfSense BSD are going to be used. You know, if you're using BSD, for example, at home as some sort of, you know, web server, then obviously no. In your particular case, it does not need to be FIPS 140-3 certified. That said, if you're trying to use um, you know, sorry, if you're trying to use BSD as convert BSD into a product that's a web server that is supposed to be used within the federal government somewhere, then yeah, that needs to be FIPS 140-3 certified. Your customer, the US government, is going to say, hey, is the cryptography on this particular OS, um, is it FIPS 140-3 certified? And if your answer is no, then you're not selling into the US government, plain and simple. So yeah, it does need to be certified depending on your use case and your customer base. I hope that answered the question.
So following to the question, the person say we are an aerospace company and some division use PF sense.
Yeah, if you're an aerospace company, then you're almost definitely selling into the US military, in which case, yes, you do need to be FIPS 140-3 compliant. I'm not, although I'll be honest, I don't know who your customers are, so I can't speak to that. But if any of your customers are selling into any kind of, defense industry or US government entity, you will definitely need to be FIPS 140-3 compliant and certified.
Thank you. There's another question. Will these slides be available for me to view after the webinar?
Oh, that's a good point. Yeah, so a lot of these slides just had data, like they were just fire hoses of data. And I apologize for that, that I should have made them easier to read. And again, some of them had links, and those links to YouTube channels are famously hard to remember. But of course, like all webinars that wolfSSL does, these will be available if you just email facts@wolfSSL.com. It's on the screen right there, facts@wolfSSL.com. Email them saying that you saw this webinar, and we will get you the slides in PDF format. Thank you for asking that question. I forgot to mention that these would be available, and I apologize.
Thank you. And there is another question. Who is the target for this product?
The target the target for this product is basically anyone who is looking to sell a solution, like a complete solution, um, that is FIPS 140-3 certified. So if you're selling a box or a virtual machine or any kind of complete operating system, um, with your application on top of it, you need to make sure that that operating system is fully FIPS certified, right? So, um, I can give you an example that Red Hat does sell their product into the US government, but they probably have some resellers who take their stuff and modify it and add their application and then sell that system to the US government. And we're looking to kind of help our customers who, are feeling a little bit uncertain about the 2-year interim certificate situation. Ours is 5 years. We have a very, very good, stable relationship with our lab and with the CMVP. They know our product really well. And we're, like I said, we're going to have that laddered approach once this certificate is expired. You are going to have certainty that there's another certificate waiting for you. And so the target audience is basically anybody who wants fully um, a fully FIPS 140-3 certified Linux distro.
Perfect. Thank you. And there's another question. If we develop and maintain our own Linux distribution for our embedded system and want to integrate wolfCrypt FIPS, Would we be provided source code to build into our distro, or would we need to provide you dev board slash cross compiler etc for you to build and test yourself?
Aha, this is a great question. And the answer is both. So wolfSSL always gives full source code. In every release, we give full source code. Okay. Um, in general, you always get the source code and you get to build it in the way that's suitable for you. Now, that said, when we do FIPS 140-3 for you, we have to get that certified. What that entails is making sure that it works in the operating environment. When we say operating environment, we mean the hardware architecture and the and the operating system or surrounding software for it. So, for example, the operating system. So yes, you would need to give us dev boards and cross compiler so that we can do all those tests for you and take all of that to the labs so that they can verify everything for that particular operating environment. But when the FIPS certification was finally done and you're looking for stuff from us, we would give you the source code. Uh,
Perfect. Thank you so much. And there's another question. Do you support PQC FIPS for my private Linux distribution?
the answer is very soon, yes. We are in the process. Like I said, we're taking that la I keep on saying laddered approach. We're in the process of doing our actually I think that we're in the process of multiple next certifications, and one of them is for we'll have the PQC algorithms included. We're talking about MLDSA, MLChem, XMSS, and LMS. All of those should be certified within in the upcoming um, certificate.
Perfect. Thank you. And there's another question. Can all of these override written libraries go into containers?
Yeah, of course. Why not? Right. So we were talking about distros. We didn't really mention too much about containers. Oh, and there was a question about target audience. Of course, containers are another target audience for this particular project. I should have I guess in the next edition of this presentation, we're gonna have to bring in containers as well. Um, yeah, there's no reason why a container couldn't be built with all of this built in. So, you know, if you already have um, your own distro and you have a container infrastructure to bring in certain things, maybe something like Docker, you could configure your Docker scripts to build all this stuff and just have it work in that container. So yeah, this containers are a great use case for this. Thank you for bringing that up.
Perfect. And there's another question. I'm new to the FIPS environment. How is wolfSSL used with disk drives that natively support FIPS 1.3?
Disks drive that natively support. Do you mean that the disks the firmware on the disk drive would support FIPS 140-3? If that's what you mean, then we would be perfectly then they're supporting algorithms that we already support. So we would seamlessly interoperate. So that would be fine. Now, if you mean that the disk drives are there, and if you don't mean the firmware, but you mean full disk encryption via the Linux kernel, then yeah, what we were talking about earlier applies. So we have our Linux kernel. The kernel overrides the kernel implementation of the crypto. We set ourselves to a higher priority, so we definitely override that cryptography. And then we get used in terms of the various kernel modules that do the encryption. Things like gnuTLS, I believe, is a good example of that.
Okay,
I
sounds
hope,
go ahead.
yeah. I was just saying I'm not exactly sure what the question was, but I hope I answered it.
Perfect. I think that's all the question I have. And thank you, Anthony, for hosting the informative webinar. Thank you, everybody, for joining the webinar today. You can keep up with our upcoming event, meet our team in person, read our blog posts, and get the latest wolfSSL update by following us on X, connected with us on LinkedIn, and subscribe to our YouTube channel. If you have any question, please reach out to us at fax@wolfSSL.com. Thank you again, and we look forward to seeing you on June 25th for Open Source Secure Boot meets Open Hardware, Wolf Boot integration with Tropic 01 Secure Elements. Thank you.